Welcome to the shop. Well, I'm continuing to learn the Haas MiniMill 2 and taking it very slow, very careful. I'm not making videos of the entire learning process because I don't want to get distracted by thinking about video and thinking about narration. I want to totally focus on carefully and slowly, not making mistakes, not breaking things, and figuring out how to get the job done. So I've created a number of special programs for automatically probing the corner of a 1, 2, 3 block placed in the vise at various different positions for various different work offsets. I've also created a program that goes through the tool change carousel and automatically measures the offset of every tool. The MiniMill has a rather serious limitation that has taken me quite a lot of effort to work around, where the tool changer only holds 20 tools and my tool library is almost 60 tools. So trying to figure out how to align the tool number in the changer with the tool offset length stored in the offset database has consumed quite a lot of time and a lot of checking and cross-checking. And anyway, I'm going to start making parts for NQALHA Production Run 5. I'm not exactly sure how many units I'm going to make, but it's probably going to be more than my usual 10. I'm thinking fairly seriously of making 20 in this run, since I already have 14 names on the waiting list, and it seems like interest is picking up. So I already have made a few parts. Like I said, in the very early stages, I'm not videoing everything that I do because I really need to pay attention and make sure that I don't make mistakes. But here's going to be the first part that I'm making, which is the top vertical arm. And I'm going to be trying something new that I've never tried before. I'm going to be trying high-speed machining to rough the part out of the aluminum extrusion. In the past, on the Tormach, I would rough the part by essentially following a contour around the shape that I was wanting to make. And this results in the tool cutting a slot. And when you cut a slot with a milling tool, it's a kind of a bad way to cut metal because the cutter is in the middle of this kind of slot and it's hard for the chips to get out, and the cutter is cutting around its full radius as it pushes forward. And then when you're done, you have this somewhat difficult to deal with waste piece. And on this part in particular, the waste pieces are kind of irregularly shaped and long, and they'll probably get caught in the chip auger. And I'm not sure how fast I can push a 3/8 roughing tool through solid 3/8 aluminum. I'm not sure how fast it'll go before I start running into chip evacuation problems and breaking cutters. So instead, I'm going to use a high-speed manufacturing or high-speed machining, HSM, strategy, and basically just turn all the waste into chips, kind of going as fast as the machine can go in a what they call a trochoidal pattern to kind of go zoom, 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 zoom around the edge at a fairly high feed rate. And never done this before, so we'll see how it goes. And I've got a GoPro set up in the enclosure, and hopefully it'll stay clear of coolant for long enough that I can actually get some reasonable video. But like everything with this machine, it's all new, and I haven't quite figured it all out yet. So here goes. NQALHA production run number 5 starts now. Okay, so I'm going to start out. The aluminum blank that I'm using is just regular extruded aluminum, and in the past I've been using it pretty much as it comes, and it's nominally 375 3/8 of an inch, but it's sometimes it's not perfect. The extrusion, the mill holds reasonably good tolerances, but it doesn't hold perfect tolerances. And also, sometimes the surface just in handling gets scarred up a little bit. So I'm trying something new that I haven't tried before, because now I have the ability to do it. I've got a 3-inch diameter insert type shell mill, and I'm going to be skinning off just a couple of thousandths off the top of the part, and this allows me to control the thickness a lot more, which is critical for this part. This part, in order to make the arm smooth and to make it feel right, the thickness of the part really needs to be accurate. In the past, when I've just used the material as it comes from the mill, sometimes I've had to do adjustments with a file on the bronze bushing to get the tightness correct. I don't like the arms to be extremely loose and floppy. I like them to be a tiny bit tight, and the difference between tiny bit tight and loose and sloppy is a few thousandths. So my new philosophy is get the material as close to spec as possible using the shell mill and the improved z-axis accuracy of the MiniMill. The Tormach did not hold Z tolerance very tight at all, and I'm hoping that the MiniMill will do a whole lot better. And then if I need to do any adjustment, the parts will either be dead on or a tiny bit undersize, and then I'll use 5/1000 shims on the shoulder bolt if I need to do any final adjustment just to tweak the thing up. So the program has been run before, but like everything else, this is new. I'm being careful. I'm gonna take the rapid down to 25% and I'm going to run in single step mode. Still getting used to this user interface. And the cutter stops at the correct pre-feed height, approximately 1 inch above the surface. And getting into position. Looking entirely reasonable. All is well. Going to be drilling here at a fairly aggressive drill profile. This is a 1/2 inch drill, and I'm using the recommended feeds and speeds for the material. This is 508 surface feet per minute and 1.4 thousandths feed per tooth. And appears to work very nicely. Using a fast peck cycle for chip breaking. In studying drilling operations, I know that some people recommend not using peck drilling, and there's a number of different strategies for controlling chip buildup and doing proper chip breaking, but it looks to me like this particular combination of feeds and speeds is clearing chips very nicely, throwing off a nice chip. Machine feels or sounds like it's operating correctly, and looking pretty good. So very little buildup on the tool, almost nothing. Now I'm going to be going to the countersink, and it's stopping at the correct pre-feed height. The Tormach, because of the rigidity problems of the Tormach, I had to kind of fumble around and futz around with feeds and speeds on the countersink to avoid chatter. The MiniMill is so much more rigid that I can pretty much almost follow the recommended feeds and speeds for high-speed tooling and still get a nice finish. So everything's looking correct. Yeah, there we go. Nice smooth cut. 2200 RPM. Feed rate about 11 inches per minute, up from the 600 RPM and 4 inches per minute that I did on the Tormach to control chatter. And the result is coming out very smooth. I'm also using a little bit of a dwell at the bottom of the drill cycle. So now, going to be drilling a single 1/4 inch hole, and after every tool change, I'm looking at the G-code, looking at the tool offset number on the tool holder, and verifying that I have the correct tool loaded because of the problem that I'm working around with the tool changer and the tool offset numbers. Lots of room to make mistakes here, and the mistakes would definitely result in a crash. Okay, so that's going very nicely. Still running at 25% rapid. So looking at my 39, tool 14, offset 31. Oh. Yeah, tool 14, offset 39, checking tool 14, offset 39, double check, cross check, pre-feed position looks good. A lot more things to check here than the Tormach. The Tormach, the Tormach was nowhere near the quality of machine that this is, but it did do tool changer management a whole lot better. So, you know, 1 step forward, 2 steps back, or actually 2 steps forward, 1 step back. Using the same drill parameters, this is the 1/64th undersize for the 7/16 reamer. it's important to ream these holes. Okay, tool offset 40, tool 15, tool offset 40, tool 15, checking H40. (250 RPM). I'm reaming these holes in order to get the best possible press fit of the bronze bushing. I probably could get away with just drilling them to 7/16 and it would be good enough, but in the past when I did that on the early prototypes, it was inconsistent. Sometimes I had a good press fit, sometimes I didn't. So, especially on the MiniMill with the improved rapids and faster tool change. So now 23, especially with the rapids and the faster tool change, it doesn't really matter that much that I'm going through the extra ream cycle, and it definitely gives me a great press fit that I don't have to worry about the bushing falling out. So now I've loaded tool offset 23. I'm looking at the G code H23, looking tool position 5, offset 23, which is a tap drill. And stopping at the right position. Okay, tool 24. So tool position 6, tool offset 24, which is a tap. Now the Tormach would do power tapping, but since it didn't have a spindle encoder and it only kind of sort of roughly knew exactly the RPM of the spindle, it couldn't do true rigid tapping and had to use these compression tension spring-loaded tap holders. And it worked. I was able to do power tapping, and because the compression tension tool tap holder was so long, the flood coolant nozzle really just hit the body of the holder and really didn't get down to the tap, and I had chip evacuation problems and broke some taps. And so for the tapping cycle on the Tormach, I always put a pause, went in with Tap Magic, gave it a little squirt of Tap Magic, and then allowed it to continue. The MiniMill supports true rigid tapping. It has an encoder on the spindle and knows exactly, with machine tool precision, servo precision, exactly where everything is, and so it can do true rigid tapping. And because of that, it's in just a regular tool holder. The flood coolant is way more powerful than it was on the Tormach, and it's aimed correctly. And so so far I've tapped just a handful of holes with the MiniMill, and it seems that power tapping works very well without the additional step of stopping, blowing off the part, putting on the Tap Magic, and then continuing. So let's check here. H24, tool position 6. Checking again just to be sure. And just a little piece of information that you may not need to know. Did you know it's possible to actually drill a hole with a tap 2 or 3 times before the tap breaks? Don't ask me how I know this. Okay, the pre-feed looks correct. Let's tap a hole. And yes, we have success. Beautiful, beautiful surface finish. Wow, it's like a work of art. Just get over here to the camera here. That is a beautiful, beautiful surface finish. So I'm going to put that off to the side here and go over to the chop saw. Because I'm trying to hold tighter tolerances on this part, I'm using a new set of freshly machined soft jaws that were machined on this machine in place in the vise, and then used the Renishaw probe to probe a 1-2-3 block, a precision 1-2-3 block in position in the soft jaws, and then use the mallet to make sure that I get good contact, because I'm attempting to hold 1/1000th on the Z height, and we'll see how it works. I am hopeful. I haven't actually run a batch of parts and done a measurement and a statistical analysis of repeatability, but I expect this machine will hold very much better Z tolerance because it's using Cat 40 tool holders, real tool holders, that should be far more accurate and repeatable than the Tormach tooling system, which was probably the biggest weakness in the Tormach, other than the rigidity and the underpowered spindle motor. But the power drawbar and the way the tool was held in the collet was definitely the biggest weakness, and that resulted, even when I was being very careful, I could not hold 1/1000th on Z position. It was lucky to be within 5. So I'm going to run the program again at full speed, full rapids, so you can see how the machine performs. Love those rapids. "600" per minute on the rapid feed for this machine. Had a tiny bit of chatter there. I might need to adjust the RPM a tad. I'm only taking a 1/1000th on the cut, so getting nice chip evacuation. Some of the larger diameter tools on the Tormach, even though I had my custom-made coolant splatter shield, it's still, some of the tools managed to soak me in coolant because the shield didn't cover the entire machine. It was kind of only about that tall. It's one thing I like about the MiniMill, it's totally enclosed, and so I don't get too splattered with coolant. Of course, the window sometimes gets a little hard to see through, and I'm hoping that the camera inside will continue to produce a usable shot, but hey, I like not getting coolant all over everything. Countersink. Got a little bit of dwell, a fraction of a second of dwell at the bottom to kind of smooth it out, even though it's just cosmetic, you know, why not do it right? If you got the option to do it right, why not do it right? I'm using stubby drill bits, what are called screw machine length drill bits whenever possible, instead of using jobber length drills, because I find that having the shorter protruding length allows me to get by without using a spot or a pilot drill. And just speeds up the operation while maintaining the required accuracy. If I do need high accuracy with a longer stick out, then I do a spotting drill operation for those holes that have to be as precise as they can. But for a lot of these holes, close enough is good enough. And with the stubby drill and the small amount of stick out, they're extremely accurate without a spot or a pilot drill. The flood coolant on the MiniMill is excellent. High pressure, plenty of flow. I didn't get the optional programmable coolant nozzle on the machine because the variety of tools that I use really doesn't require it, and the stock coolant nozzles seem to work very well. So that is just a beautiful part. So far so good. I'm gonna run some more of these parts. This is the first operation. I'm gonna run some more first operation parts and then switch over to the second operation. And I'm not sure if I'm gonna actually show on video the setup of the second operation because I'm still, like I said before, I'm still somewhat new at the machine and want to really pay attention to what I'm doing and not get distracted by video. So anyway, see you later for the second operation. I'm setting up for the second operation now, and I need to be very careful about where my reference point is. I'm trying to chamfer and skin the bottom side of the part, and if I just turned it over like that, I probably wouldn't get the results that I want, because these edges were just cut with a chop saw, and they're kind of sort of close, but they're not really accurate. This point is my reference 0 that all these holes were drilled relative to. So if I just flip the part over like this, now the material width would have to be perfect, and the perpendicularity of this would have to be perfect, and I know they're not. So in order to preserve this reference point, I have to flip the part this way and move it up against a stop on the vise using a different work offset. I would be using work offset 5 instead of work offset 3. Now, in the past, on the Tormach, I would just whip out the Heimer and measure the corner, but now the new machine has the probe. So I wrote a little probe macro, probe program that will probe the top of a 123, a precision 123 block, and then the outside corners, and then actually modify, subtract the thickness of the 123 block so that the 0 for that work offset is set to the ledge that the part sits on. So let's go ahead and run this probing program. And the probe is an expensive and delicate piece of equipment, and the machine rapids, oh, the thing works so fast, and it would destroy that probe long before I could even push the stop button. I mean, if I was really paying attention and had really fast reflexes, it would still just destroy the probe. So fortunately, the probing software, the Renishaw macros that come with the probe, fortunately the probing software has what's called a protected move. And that means it can move to position when it's not expecting to hit something. And if it hits something, it stops the machine and flags an error. And of course it moves at a safe rate so that the machine can be stopped in time to prevent damage. So I'm going to rapid to machine coordinates of a fairly good distance, 4 inches above the surface, which I know is always going to be safe and not dependent on work offset, and then do a protected move that will get into position and then execute the probing macro. So let's probe that corner. Starting up the probe, probing the Z position, move over, protected move down, probe the outside corner, and then the G code has a line in there where I can adjust the work offset Z position by subtracting the thickness of the 123 block, which is 1 inch. So now the 0 position of work offset 5 is set to the ledge of the soft jaws and the back corner with the stop. So now I'm going to take out Mr. 123 block and got my part marked with the reference position. Give it the old whackaroo. Gotta be careful swinging this hammer. I don't want to get the upstroke to hit Mr. Probe. Probably should put the probe away before doing Mr. Hammer. So many things to be aware of with the new machine. So, let's go over here. And need to double check that I've got the correct G code loaded. So it's off to the CAD room. And yes, this will be the first time that I run this program, so wish me luck. I'm still very far away from being an expert on this machine and trying to be as careful as I can be. So going to be limiting the rapids to 25%. And I can already tell that this is wrong. So, and I know exactly why it's wrong. The added complexity of manually working with the limitations of the tool carousel, that I have the tool carousel set up so that a standard tool set is 14 tools, and then I have 6 that are kind of like the optional tool set, and I have 4 sets of 6 that are the standard options, and then for parts that don't use one of the 4 standards, I have specials. Now, I haven't yet completely optimized my sets so that all of the most common tools are loaded in the correct positions. I'm experimenting. I just recently started using the shell mill for doing the skinning operation, and for the previous part, the shell mill was loaded in a different position because I was using a special tool set, and, well, got loaded the wrong position now, so let's oh, so many things to remember. I think eventually I'll probably get used to this and just develop the habits of doing it correctly. But for now, in the beginning stages, so many things to remember and so many opportunities for error. So what I forgot to do, and this is a habit that I need to get into, is every time I change a program to put the appropriate setup sheet on the clipboard and look over here and see that, yes, in fact, I had the wrong tools loaded. As I get more comfortable using the skinning operation, I'll probably move the 3-inch shell mill into one of the standard sets and hopefully adjust things in such a way that having a special set is rare, almost never, and that almost every part that I need will be made with one of the 4 standard sets. So let's tool 14. So I'm going to set it up correctly here with the large countersink, which is tool offset 43, going into tool position 14. So, double check, triple check. Tool 43 going into position 14, position 14. So now tool offset 58 is going okay, so that looks correct. So now let's return to the program and see if it goes any better this time. Loading the correct tool. Still got the okay, single block mode. Pre-feed looks correct. Tool looks correct. I changed my feed and speed a little bit, taking a very light cut, just taking like 1/1000th and a half here. And got the rapid slowed down to 25%, loading the countersink, which is correct. Activating single block mode. Pre-feed looks correct. Feed looks correct. Rapids back to 100%. And second operation is looking very happy. And we return to the unload position. An amazingly beautiful surface finish has been produced. Let me check with the caliper here. Not sure I like that. Not sure I like that at all. So, I'm going to do a little troubleshooting, try to figure out what's going on here. I'm new at this, so we'll see how it's going. But project continues, moving forward one step at a time, learning as I go. So I checked a couple of things, got out the nice micrometer, checked. The part's a little undersized. I was hoping to get better accuracy than I got, but when I think about it, there is quite a lot of tolerance stack up going here. Even though the soft jaws were made on that machine as accurately as I could figure out at the time, there are two sets, the left and the right. And when I set the 0 using the probe, the 1, 2, 3 block was on the right side, and it looks like the left side is just the tiniest bit different. And so it's not as close as I would have liked them to be, but there's always the question of how close do they need to be. as I learn to use this machine, I'm trying to see, well, how accurate can I make things? And could I make a part within a thousandth? Could I make a part within a half a thousandth? And it appears that this operation, no, I can't make a part within a thousandth. But when I took one of the parts that I made and assembled it, pressed in a bushing and put a shoulder screw on and tightened it into position, it fit just perfectly. So I think it's probably good enough to get the job done, but there's always this, learning this machine is going to be a process, and it may turn out that if I ever did need to, absolutely needed to hold a thousandth or less, I might have to go through a little bit of extra work and a little bit of extra care, and it's all part of the adventure. So I'm going to run one here at full speed, just so anybody that's interested in seeing what it looks like at full speed can see what's going on. So very carefully sure that, oh, there it is. Not the Mr. Kerwacker. In the past, when I just used the material as it came from the mill, some of them fit perfectly, some of them were a little too small, some of them were a little too large, and the ones that were a little too large, I ended up having to hand fit with a file. So I'm hoping that if I have errors, apart from perfection, if the part is off a little, I'm hoping that it's off in the undersize as opposed to the oversize, so that I can fix it with a 5000 shim instead of having to whip out the file. So 100% rapid and single block mode off. Let's watch this guy run at full speed. Love those rapids. The 3-inch index shell mill produces an absolutely beautiful surface finish. On the Tormach, when I needed to do an operation like this, I used a single cutting tool, fly cutter, and it also produced a good surface finish, but needed to be run a lot slower because it only had one tooth. This guy has 6 indexable faces, This cutter has 6 inserts. Each insert has 4 cutting faces, and I'm using the insert geometry that's optimized for aluminum. So here we go. Second operation is looking very nice. As soon as I get done running the second operation parts, I'm going to set up to do the high-speed machining operation for the third operation. So I'm going to turn the camera off, run some parts, and come back later for some hopefully exciting high-speed machining action. After lots of work and study and frustration and going back and trying again, and wow, there's a lot to learn about this machine and the new machining techniques, I believe I have high-speed machining working. Probably not completely optimized. I can probably tweak it up just a little bit more to get it to run a little bit better. But hey, it's making parts. So here goes. High-speed machining. NQALHA Production Run 5, vertical arm top on the Haas MiniMill 2. So let's start this pig up and see if we can make it oink. (10,000 RPM), Lakeshore carbide, 3 flute solid carbide, zirconium nitride coated, special for aluminum end mill, and let's see, 240 inches per minute feed rate, 100,000 step over, and full depth of 3/8 of an inch. Using what appears to be a maximum of, oh, it's hard to see because it goes by so quickly, 70 or so percent of spindle horsepower. Then I'm going to be running a finishing pass with a 3/8 Lakeshore carbide, 3 flute, running at 90 inches per minute, taking off that last little 15,000th remainder that was left after the roughing pass. And that is a spectacularly beautiful surface finish. Best parts ever. Machine is performing well. So I have one more hole to drill in the end. I'm not sure I'm going to show that on video. I'm also unsure if I'm going to show every single step on every single part in this sequence, in this series, this production run. I'm still undecided. I'm certainly going to show the more interesting stuff, but whether or not I show every single detail remains to be seen. So that does it for the outside protocol. I'll decide whether or not I'm going to show the drill in the end. Not sure how interesting that is. So that's the end for now.